The enzyme-substrate complex is formed during a chemical reaction. The substrate may still dissociate from the enzyme. The substrate bonds to a small area of the enzyme termed the active site. When the enzyme is bonded to the substrate, we call this the enzyme-substrate complex. Once the reaction is complete, the enzyme releases the product and is ready to bond with another substrate. In competitive inhibition, an inhibitor may bind to an enzyme and block the binding of the substrate, for example, by attaching to the active site. This is called competitive inhibition because the inhibitor competes with the substrate for the enzyme. During non-competitive inhibition, the inhibitor does not block the substrate from binding to the active site. Instead, it attaches at another site and blocks the enzyme from doing its job. The inhibition is said to be non-competitive because the inhibitor and substrate can both be bound at the same time. Allosteric regulation is just any form of regulation where the regulatory molecule binds to an enzyme someplace other than the active site. When an allosteric inhibitor binds to an enzyme, all active sites on the protein subunits are changed slightly so that they work less well. When allosteric activators bind to locations on an enzyme other than the active site, there's an increase in the function of the active site. In the process of feedback inhibition, the end product of a metabolic pathway acts on the key enzyme regulating entry to that pathway, keeping more of the end product from being produced. Typically, feedback inhibition acts at the first committed step of the pathway, meaning the first step that's effectively irreversible. The pathway steps regulated by feedback inhibition are often catalyzed by allosteric enzymes. If the temperature or pH of a protein's environment is changed, or if it is exposed to chemicals, these interactions may be disrupted, causing the protein to lose its three-dimensional structure and turn back into an unstructured string of amino acids, hence the denaturing of proteins.